All right, welcome to lecture 24, part B. So in this part, we're going to keep looking at problems we can do with the ideal gas law. So what do we do in part A? Well, part A, we basically talked about, well, this equation and how if I give you 4 out of the 5 things, you can solve for whichever one's missing. All right. And the other thing we brought in is, N is moles, so you can actually also use grams or convert to grams if you need to. All right, so with that, what are we going to do in this part? Well, in this part, since we have an equation that involves moles, PV equals nRT, N is moles, since we have an equation that involves moles, we can then go back and talk about how this relates to other topics that involves moles. And specifically, we're going to look at how we can use PV equals nRT and relate it to stoichiometry. Oh, what the heck was stoichiometry? How much stuff you make in a chemical reaction. All right, so yeah, we're back to that for a little bit. How much stuff do you make in a chemical reaction? All right, so let's do an example. Let me find our first example here. Okay, so let's take a look at a little example here, an example that involves a gas. And hopefully this is not a reaction that you ever have to undergo. It's the reaction that actually is used to inflate an airbag, like in your car. So, if you get in a car accident and you don't want to get hurt, and if it's a big accident, one thing that's going to happen is there's these airbags that are going to blow up to protect you, right? Now, the way they blow up, there's not like a pump in your car that pumps the airbag up. That would take too long. So the way that they are inflated is a chemical reaction. So the compound they start with, it's a little different the way, it's not really named the way you're used to it. It's called sodium azide. So they put a little sodium azide in your steering wheel or wherever. And then what happens is if the car detects a crash, like there's sensors all around the car, if it detects a crash, it starts a chemical reaction and it creates nitrogen, which is a gas, and that nitrogen inflates the airbag, in a millisecond or something, some ridiculously fast speed. Okay, so in this example, let's say I wanted to figure out, well, we're going to do this reaction, and I want to know how much nitrogen we're going to make. Now, I'm not going to talk about the amount of nitrogen as like how many grams of nitrogen are we going to make. Since it's a gas, I might be more interested in like what volume of nitrogen are we going to make? Like, are we going to make a liter of nitrogen, 3 liters of nitrogen? And that's what this question is all about. So it says if you start off with 11.2 grams of sodium azide, and they tell you the pressure it reacts with and the temperature, what volume, in other words, how many liters are we going to make of sodium azide? So the way to figure this out, it's basically stoichiometry, right? So how many liters are we going to make? So when we did this before, do you remember how I wrote up this chart? Like grams of A goes to moles of A. And then we could go from moles of A to moles of some other compound B. And then moles of B back to grams. Well, all right, that's how we did these stoichiometry problems in a previous chapter. We started with grams, and I asked you about grams. Now, in this one, I'm not asking you how many grams of nitrogen you can make. I'm asking you how many liters of nitrogen you can make. So a lot of it's going to be kind of the same. We're going to start off with our grams of sodium azide. We're going to convert it to moles. So how are you going to do that? Oh, that'll be the periodic table, right? The number on the periodic table, that's how many grams makes a mole. And then once we know moles of sodium azide, then we'll move on to moles of what I'm solving for. That's the nitrogen. So moles of one thing to moles of something else. Oh, that's your coefficients again. Now, at the end, before, we went from moles back to grams, right? So we went from moles to grams, and the way we did that was we used the periodic table again. Now in this problem, I'm not asking you for grams. So that last step, we're going to do something different. I'm not going to try to figure out the weight of the nitrogen. I'm going to try to figure out the volume of the nitrogen. So we're going to take a little detour here, and we're going to go from moles to liters. And the way you can go from moles to liters, oh, that's what PV equals nRT is all about. It relates moles to volume. Now you need some other numbers too, but like temperature and pressure, but I think we have those, all right? So that's kind of the outline of this. I'm gonna flip over to another page where I have a little more room and we're gonna work this out, right? So we're gonna go from moles of what we have, grams of what we have to moles of what we have, moles of what we have to moles of what I'm asking you about. And then once we get moles, it'll be ideal gas law time. We'll solve for liters. All right, so with that, let's do it. Okay, so let's go ahead and try to work it out. All right, so let me read the question again and try to get a little organized to start. So if I start off with 11.2 grams of this, what volume, so I guess that kind of means liters, how many liters of nitrogen am I going to make? What volume of nitrogen? All right, so if you look at the question, they've given us some numbers. They've also given us a pressure and a temperature. If you're wondering where do those fit in, well, pressure and temperature, that kind of has to do with the gas. So, so we'll use that when we're ready to use the ideal gas law and start worrying about about the amount of nitrogen that is. All right, so with that, let's go ahead and work this out. So first thing I do, like we talked about a minute ago, you really got to take the grams of this and convert it to moles. So that means you got to first use your periodic table. So I'm going to take the weight I have of the sodium azide, and I'm going to go to moles of sodium azide. Grams to moles. All right. That means, just to remind you, oh, that's the periodic table, isn't it? All right, so I'm going to give you a second. I want you to kind of be practicing this with me, I hope. So you need to add up the weight off the periodic table. So you need to add up a sodium and 3 nitrogens. Go ahead and do it. Tell me what you get. Okay, it should add up to, let's see here, I think it's 65 if I remember right. Let me do it. 1 sodium, 3 nitrogens. You put it all together, 22.99 and 14, you triple 14, that's 42.03. Yeah, you put it together, you should have gotten 65.02. All right, 65.02. What does that mean? 65.02 grams equals a mole. All right, so with that, we're going to use that 65. I got to go from grams to moles. Looking at my units, grams are here. Put grams on the bottom. 65 goes on the bottom. The 1 mole goes on top. So if you work it out, we have started with 0.172 moles of this compound. All right, moving on. Now we know how many moles of this we have. Now we're going to convert it to moles of nitrogen. So when we do this reaction, we're not going to get 0.172 moles of nitrogen. We need to think about the coefficients to see how many moles we're going to get. So the coefficients allow you to go from moles of one thing to moles of something else. So let's go ahead and take that answer we got for the amount of sodium azide. And then let's solve for, I'm looking for nitrogen. Let's solve for moles of nitrogen. All right, it's coefficient time. Oh, let's see if we can do this out. What number, let me ask you a couple questions here. What number, when you're converting and you're looking at those coefficients, what number are you going to put on the bottom? Oh, it should be the coefficient in front of sodium azide. That's a 2. And then what number are you going to put on top? 3 moles of nitrogen. What you're solving for goes on top. Does that look right? I think it does, right? Sodium azide cancels. Goodbye. And now we have nitrogen. All right, if you work it out, you should get this number, 0.258 moles, 0.258. All right, so with that, we now know how many moles of nitrogen we're going to make. So we should, because they also told us the pressure and the temperature, we should be able to figure out the volume. All right, so now what we're going to do now to figure out the volume, if you know the moles, you can solve for volume. It's going to be PV equals nRT time. All right, kind of running out of a little room here on this tiny screen. Let me erase a little bit. We'll keep working up here. All right, we already did this step. All right, so let's see here. And I like to make a little list. I don't really have a lot of room, so I guess I'll try to just to fit it in here, right? So we have the pressure. That's what this number is. If it says atmospheres, that's your pressure. V is the volume. That's what I'm looking for. N is your moles. Now, and then we get R. R is that number you've been using in the last part, right? 0.08206. And then we get T. T is your temperature. T is your temperature. All right, so the temperature would turn out to be, oh, did they tell us? Oh, 11. Shoot, though, that's in Celsius, isn't it? So we can't do that. We can't do that. You have to convert it to Kelvin. So you add 273. On the Kelvin scale, it's 284. All right. All right, so with that, I think that looks pretty good. Now we just got to solve for V. To solve for V, we need to divide, don't we? Divide? What do you want me to divide by? You're going to divide by 1.18. You're going to divide by 1.18. Because that's going to make that cancel out on the left. And what you're going to end up with is this. Oh, I got to erase a little bit more. Get rid of this. We're done with this part that was earlier. So this is what you would get. All right. If you work it out, V, the volume, it turns out you're going to make, I got 5.10 liters. You could try it on your calculator, make sure that's going to work. All right, so that should be your answer. All right, with that, I think, these problems take a little while. Do you know what? I was thinking of maybe doing another one, but maybe we'll save that for our Zoom session. I'll show you one more along these lines during our Zoom time. We'll see how, that way at least you've seen one, but I'll show you another one in Zoom and then we'll do a little practicing. All right, that's it for part B. We're going to move on to part C in just a minute or two here. All right, one more little thing to let you know about.